Okay, so in this video we're going to solve a system by substitution, and this is the first part of a three-part video series that I'm going to do because our systems are going to be slightly different. So here we have our system and we're going to solve by substitution. Now if you notice the difference or the way this system looks, both linear equations are in slope-intercept form. That is actually the simplest form we can have these in to use substitution. So the first step that we want to do is we're going to label our equations because we're going to do a lot of writing and rewriting, and we don't want to lose track of what our original equations were and which one and which equation is 1 and which one's equation 2. So when we solve by substitution, we're basically going to take one equation, doesn't matter which, and substitute into the other. Since it doesn't matter which one we do, that gives us a little bit of some flexibility. We have to decide which would be the better way to go. So if you look at this problem, if you noticed that both equations are solved for y, that's our first step to solving by substitution, is that we want to solve a variable for one of the equations. Now, they're both already solved for y, so we don't have to do any solving at all. So what we can do now is move on to step 2, which basically is to substitute. Well, since both of these expressions with x are equal to y, that means they're equal to the same thing, therefore they are equal to each other. So what I'm basically going to do is just take this one right here and put it right into y right there, because this is equal to y, and in my second equation y is right here, so I can replace it. So I'm going to substitute x plus 3 into y, and when I do that I get x plus 3 equal to, and the rest of equation 2, 2x plus 5. Now some of you might be wondering, well, why didn't I put 2x plus 5 up here for y? I could have done that. I still would get the same answer. I'm just going from equation 1 into equation 2. So now I have my equation. Now I'm going to solve for x. I'm going to remember all the little skills I learned back from chapter 2. What that means is I'm going to use my inverse operations. I want to solve so I end up with a positive variable here. Use my inverse operations again. So I basically get negative 2 as my value for x. Okay. Now that we have our value, we need to take our x and plug it back into one of the original equations. It can be equation 1 or equation 2, it does not matter. Because now that we know x, if we put them back into one of the equations here, we can solve and figure out what y equals. And remember, the solution to a system is an ordered pair. Okay, so I'm just going to go ahead and put it back into equation 1. That seems a little bit simpler than equation 2. So x equals negative 2, so that means we're going to have the following setup because I substituted this. So y equals a positive 1. Now, so my final answer is negative 2 comma 1, because remember it's an ordered pair, but I have to check this to make sure that I did this correctly. So I'm actually going to take this solution and substitute back into the equations to make sure that we get the correct answer. So negative 2 for x, 1 for y. This works here. And then now for the second one. One for y, negative 2 for x. One does equal 1. So it works. So there is my solution.